Hello, everyone. You are welcome to today's lesson. And today's lesson is going to be a very brief one. We are going to look at the solution to the assignment that was given in lesson 2 on the topic rational functions and partial fractions. Okay, so as you can see on your screen, this was the question we were asked to express 2x plus 5 all over x squared minus x minus 2 as partial fractions. Okay, so quickly, let's go and look at what the solution. Okay, all right. So as you can see, okay, so this is it as usual. When a question is given, okay, what do you do? The first thing that you do, read a question and underline the salient part, if any. So here you are asked to express it in partial fractions. Okay, so you have to go beyond the identity, remember, whenever you are asked to resolve or express that in partial fractions. If it's the identity that we want, we will tell you to write it, okay, in terms of what's the identity. Okay, so I guess my point is well made. So after that, the first thing that you write is solution. After that, you extract the given information or whatever that you need to express in partial fraction or as partial fractions. So given, okay, we extract this. Okay, remember, we said anytime you are resolving any rational functions into partial fraction, your first question that you ask yourself is, okay, the rational function that I'm dealing with, is it proper or improper? So here, how do you make that determination? The degree of the numerator is 1. That of the denominator is 2. So obviously, we are dealing with a proper rational function. Once it's a proper rational function, and it means we can go ahead, okay, and resolve, okay, straight away into the identity. That is what I mean. So in this case, what do we do? If you come to the denominator, remember before you can write the identity and after that move on to the resolution. Okay, check the denominator. The denominator factor, only one factor, but it's a quadratic denominator, which is factorable. So once it's factorable, you know, pick it out, go and factorize as your rough work, and the rough work is done here. So this x squared minus x minus 2 factorizes into x plus 1, x minus 2. You are expert in factorizing this. Even with this one, because it's a special one, okay, that is the leading coefficient is what? 1. That the quadratic expression that you have here. You can straight away factorize without going through the whole of this. So I will know, what do I do? Okay, just by the way. So what do you write? You get 2 factors, 2 linear factors. Okay, the first factor x, this will also be x. You look for the factor pair. So the factor pair, what do we have? Of minus 2. Okay, that's when you multiply, you get minus 2, you add, you get minus 1. That will be minus 2 and positive what? 1. So it will be plus 1, then minus 2. You get your denominator straight away. So it means this will be equal to, you keep your numerator, then you factorize the denominator, which gives you what you have here. Remember, it will be equal to, it's an expression, it will be equal to. However, at this point, that's your denominator, you have factorized that into the linear factors. You can now write the identity. And when you are writing the identity, you don't forget to use the identity sign because you are going to introduce letters. Because you have 2 linear factors, okay, what do you do? Distinct linear factors. It means we are going to get 2 fractions. The first fraction, the denominator will be your first factor. So because your first factor is linear, the numerator will be constant. Same for this one, linear denominator factor. So the numerator will give you a constant. So at this point, what do you do? Remember, the next step is to write this partial fraction identity, okay, as what? A single fraction. So at this point, after writing the identity sign, when you introduce your letters or where you introduce your letters, the rest will be equal to. So this will be equal to. Then what do we do? You take the LCM. The LCM will be x plus 1, x minus 2. And I've told you to always be the same as what we have here, your set of factors in the denominator. Okay, so at this point, you ask yourself, x plus 1 will go into the denominator here, how many times? It will be x minus 2 times, then times your a. You write it here. Then plus, okay, x minus 2 will go into, what do you call it? the denominator here how many times, and it will be x minus 1 times, then times your b. You write it also there. So don't forget to put your s minus 2 here and the s plus 2 plus 1 in brackets, because they are binomial. As for the a and the b, you can choose not to put it in brackets because it is a monomial. So at this point, remember, you are saying that indirectly this fraction here is equal to this fraction. So once the denominators are the same, it implies that the numerators are the same. So just go and equate the numerators, remember. So after equating your numerators, now we are going to use the cover-up method. I told you that there will be an alternative method, which is what? The method of comparing coefficients. But remember the advice. I said immediately your factors, okay, all of them are linear factors. Okay, use the cover-up method, it's better. Okay, so here we've seen that our factors are linear factors. So the cover-up method will be the one that we are going to go for. So if I want to, find the A first, then I have to cover the B. So if I want to cover this, okay, what do? I have to make sure that the B will go. And the B can only go when the s plus 1 here is 0. So you equate this one to 0 and solve for your x. So it means you have to go for if x is equal to minus 1. So if x is equal to, I've told you in books you see when, but don't use when. If, okay, you save time, however, letter. So you substitute, you simplify, and you come and get, okay, this will give you minus 2 plus 5, and that will give you 3. And this one will give you minus 3 times a, so minus 3a. This will give you 0. So you don't write. Remember, you write it again, then you divide. At this point, you get a to be equal to negative 1. Okay, then now you come and solve for or cover up the a to find your b. So if you want to cover up the a, then it means you use this factor. Okay, this factor must be set to 0. You want this to be 0. So you set it to 0 and solve for x. So x by inspection will be, you can do that mentally just as I did for this. So x will be equal to 2 here for this to be 0. So if x is equal to 2, the same explanation. Okay, so substitute, this will give you 2 times this, which will give you 4. 4 plus 5 will give you what? 9. And it will be equal to this. Okay, we'll go because you get 0 here. That was your intention. Then you get 2 plus 1, which is 3. 3 times b. So you get 3b. You rise again before you divide. So now that you know the values of your a and b, then you are done, almost. Okay, in fact, you are done. It's just your conclusion. So therefore, whatever that you are giving here, remember the next step after getting your letters that you introduce, their values, go and substitute that into the identity that you wrote. So in this case, it will be thankfully a. Okay, so yeah, sorry. A is what? Negative, and B is what? Positive. So remember I said start with the positive first, if possible. So in this case, I'm going to start with this term. Okay, first. So the b is 3. So it will be 3 over x minus 2. Then minus. In actual fact, it should have been this. Okay, I've told you are mature, so you shouldn't do that. So you were supposed to write whatever that you have here is equal to your minus 1 over your x plus 1, then plus 3 over x minus 2. Then it's better, okay, to start with a positive. So you will now come and swap, okay, and you have one more step. Okay, but remember, we are mature, so we always think before writing. And after thinking, we realize that we have to write this term first. So, followed by the negative. Okay, so that will give us what we have here. And this was the expected solution from you. So, I have addressed all the major concerns. So, be very careful when you are substituting and you are performing your algebra, your simplification. That is key. Immediately you get this right. Okay, if you get anything wrong here, then it means it is your algebra that has exposed you, or that will expose you, because this is the biggest knot. If you're able to write the identity, the rest you should be able to deal with it, especially when the factors, okay, the denominator factors, okay, are all linear. So on this note, thank you very much. Okay, God bless us all for a wonderful lesson.